Welcome to Section 2.5, Introduction to Relations and Functions. So we have two questions. The first question, what is a relation in math? Well, in math, a relation is simply any set of ordered points. For example, something like x, y. Okay, and then the next question is, what is a function in math? So function is a special type of relation. So for example, if you think of, let's say I told you there's the world of dogs, right? And underneath dogs, you have, let's see, a Labrador, or you have maybe pugs, right? Well, relations are a certain type of item, and underneath relations, we have something that are called functions, and then they're the ones that are not functions. So we're looking at a special type of relations when we're talking about functions. So they're ordered pairs, but they're specific types of ordered pairs. So they are ordered pairs where, and this is very important, each x value has only one corresponding y value. Now this is specifically when we're talking about an x and y, so if you wanted to be more generic, you could say where each first value has only one corresponding second value, if you wanted to be a little more generic. But usually with math, we're talking about sort of an x and y relationship. Or at least in this class, we are doing that. So example 1, determine whether the following relations are functions. Okay, so we're told they're relations, and we look at them. Yep, they are coordinate sets. So now we have to figure out if they're functions. Well, what makes a function a function? It's if the x values have only one corresponding y. So to determine this, let's go ahead and set up an xy chart, or an xy table. And let's list out the x values we're given. We're given 1, 2, and 5. And what are the y values we're given? We're given 3, 4, and 3. So yeah, each x value has only one corresponding y value, so this is a function. Let's go ahead and state that. This is a function. Now let's check the next one. We'll go ahead, set up our little table of values here, and write down our x and our y values. So we'll go ahead, pick our x values, so we have the -4, 2, and -4. Actually, you know what? We already had -4 written. So let's go ahead and erase that duplicate. And let's see. And then we have 1, 4. Ooh, and -4 also has 3. Does this fit the definition where each x value should have only one y value? The answer is no, it doesn't. Because our x value of -4 apparently has two different matching values. So this is not a function. It might be some other type of relation, but it's not a function. Okay, so this is not a function. It does not fit the definition of a function. So once again, at some point, mathematicians were like, you know what? Let's focus on this certain type of relation, and we'll call it functions. So that is the ones we're looking at, where each x value has one y value. Now, functions can be given in the following formats. So the first format we can have is a set of ordered pairs. For example, x, y, and so on. Another way that functions can be given, or something called a correspondence or mapping. Or mapping. Where we have them set up sort of in their little set values. We have the x ones written here, and the y's written here, and we compare them. The next way we can look at them is at a table. So we have x and y table. Another way to look at it would be a graph. This is one we're often using is a graph. For example, if we went ahead and we plotted down our points. And let's see, the last way that we can look at them is something that's called a rule. Another way to look at that would be an equation. So for example, the equations we know for like equations of lines, y equals mx plus b, that would be called a rule or an equation. And this graphs out some kind of line. Okay, so these are the ways that we could be seeing formulas. Functions. Usually in this course, we're going to be given functions either with a graph or a rule, otherwise known as an equation. Now let's take a look at something called the domain and range of a function. So the domain and range usually refers to the x and y values. So the domain is talking about all the x values that can be used. Now this is a pretty loose definition. If you want the main definition from the book, feel free to go ahead and read your book for this section. And then the range is all the y values that can be used. Okay. And the more generic term for these, so instead of the x values, we would call it the independent variable. And the y value is usually called the dependent variable. Okay, I usually don't use the terms independent variable or dependent. I usually use x or y. Another way to think of this, in terms of domain, if you think of something like the domain, a person's kingdom, their domain, that's talking about the land space that that little kingdom owns, right? This is my little sad version of a castle. It's not going well. My little castle, here's my little tower triangles. Where's a flag? There's a flag, right? Okay, so the domain is the area in the bottom, right? We think of domain, area, the flat area, right? Which would make sense for the x values on our coordinate plane. Now the range, we think of shooting, right? So shooting range, that's usually when a person, maybe they have a bow and arrow, right? They shoot an arrow and it goes up, right? So that's when we're thinking of up and down, which matches with the y values. So y values are your range, up and down. X values are the flat, your domain. So now let's take a look at example 2. Determine whether the following are functions and what the domain and range are. Okay, so we're given, let's see, this is coordinate points. So we need to determine the domain and range and then determine if it's a function. So let's first go ahead and determine if it's a function. I'm going to go ahead and use my table here, comparing my x and y values. So my x value is 9, -1, -7, 8, and another -7. We won't write that down. I have a suspicious feeling this is not a function. So 9 has -5, -1 has -9, 7 has 1, 8 has -5, 7 also apparently has a 4. So this is not a function. But we can still write down the domain and range. So the domain is all the x values, so that's going to be, we'll put it in some notation here, 9, -1, -7, 8, and we already wrote -7, so we'll leave it like that. All of the x values. Now the range is all of the y's. So -5, -9, 1, -5, and 4. And there we're done. Y values. Alright, let's take a look at the second example. We're going to determine whether this is a function or not. So, let's see. These are, which one is it x and which one is our y? Well, they're not really written as x or y. What they are written as is sort of the input and the output, or the independent and the dependent. But I'll go ahead and call these just my x and my y value. And we're going to see, does each x value only go to one y value? Yes, it looks like each one only goes to one y value. Now you might say, well, what about that 4 there on the y? It has 2 x values. We don't actually care about that. We only care if the x has more than one y. Okay? So, since each x has only one y, this is going to be a function. So what is the domain and range? Well, the domain is just the x values. So these ones right there. 2, 4, 5, 8, and 9. The y values are all these right here. 2, 3, 4, 7, and 8. And there we go. Now let's take a look at example 3. Ooh, this is given in the graph format. So notice we're not talking about the connecting of all of these lines. We're not looking at that. We're looking at each of these specific points. So how many are there? 1, 2, 3, 4, 5, 6 points. Now, is it a function? Well, it's kind of hard to look at it from what we have here. Let's go ahead and do a table of values. So I'll go ahead and highlight my x values. Boop, 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 boop. And my y values. Boop, 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 boop. So you might see something already, but let's go ahead and follow along with this. So x is -5, -3, 0, 2, and 1. Let's write down the matching y's. -1, 2, 3, 0, 3, and 1. Aha! My x has 2 y's. So is this a function? The answer is no, it is not a function. But we can still create a domain and range. So the domain is going to be all of the x values. And the range, once again, will be all of the y values. Oh, I didn't need to rewrite 3 twice, but that's okay. Let me actually go erase that. Okay, so this actually leads us really well into the next concept. So the next concept, before we get there though, you'll notice that if you see the two x values that have the same, if you see the x value has the same 2 y values, they're on top of each other. So the same x values had different y values, and those points were on top of each other. They create something called a vertical line. This leads us into something called the vertical line test. So, with the vertical line test, if I can drop a vertical line through your graph, and it hits more than one point, it is not a function. Okay, so if we drop a vertical line through the graph, so notice this only works with graphs and trying to figure out if it's a function. It doesn't work with any of the other methods. So if we use a vertical line through the graph and it hits or passes more than one point, it is not a function. Because if it hits more than one point, we have an x value that has 2 different y values. Okay, so this is a great test if you're looking at a graph. Let's go ahead and practice it. Determine whether the following graphs pass the vertical line test or not. State the domain and range. So let me go ahead and fix something that is wrong with our graphs. Remember, we always want to have arrowheads on our graphs. Let's go ahead and plop those in. Okay, so now let's go ahead and drop a vertical line. You might say, well, I could drop a vertical line here, and look at that. It doesn't hit anything. So it's a function. That answer's not really. We need to drop a vertical line, technically, anywhere, and if it never, ever, ever hits more than one point on my graph, then it is a function. And notice with this thing here, the green one, it's called a parabola. It only hits my graph in one place. So this is going to be a function. This is a function. Actually, let me just go ahead and write that in black. So this is a function, because my vertical line only hits in one place. So I'm going to say this is a function by the VLT. Okay, so you need to state the vertical line test, and you can call it VLT. The reason you need to state it is because it doesn't require a lot of work. So state it, and we will both feel happy because you'll get the points, and I'll be able to give you a high grade, hopefully. All right, so what do we need to do next? Domain and range. So the domain, oh, this is weird. I can't list out the x values. Usually I list them out, right? But if I tried to list this point, I'd also have to include that point and that point and that point and that point. And oh my gosh, how many x values are used? In between 0 and 2, there are like infinitely many numbers, right? So I can't just list out my x values like I used to do. So when you can no longer just list them, you're going to go ahead and use interval notation instead. Okay, so shifting gears, we'll use interval notation. Now let's just focus on the x values that are used. So the x value that we use to the farthest left, well, that arrowhead indicates that we're going to keep moving into that direction. So we'll start at negative infinity. And then we're going to keep going all the way, and that arrowhead indicates that we'll still be going out to the x values to positive infinity. Let's take a look at range. So range is instead looking at the y value. So let me go ahead and clean up my graph so I can show you this a little better. So range is looking at the y values. So we're going to find the smallest y value we use, and then up to the largest y value we use. And let me go ahead and draw my arrowheads back in. Okay. So what is the smallest y value we use? Well, it's that value right there. So that would be negative, what, 4? Yeah. And we include it. And then my y values go up, 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 up. How high do they go? Well, those arrowheads indicate they're going up. So that's going to go all the way up to the biggest number in the world, which is, well, we don't know, so we call it infinity. All right, let's move on to the next one, b. Ooh, what is that? That's a circle. So let's go ahead and drop some vertical lines. We drop a vertical line right here, and boop. Ooh, let me change colors. And it goes boop. 1 point. Well, I could be satisfied and say, hey, yeah, this is a function. It only hits 1 point. But that only happens in one place. If I drop a vertical line anywhere else on my circle, what do you see what happens? Each line hits 2 points. And this is, oh, humbalala. Okay, this one is not a function. So this is not a function. And once again, we state our reason by the vertical line test. You can use VLT for vertical line test. Okay, why is it not a function? When I dropped this one vertical line, it hit my graph in 2 points. That means it's not a function. Okay, so now let's go ahead and take a look at the domain and range of my function here. So domain, we'll focus on x values. What is the smallest x value we start with? Well, it looks like this value right here, which looks like that should be negative 3. And we include it. And then we keep going until, boop, we hit right there, which is positive 3. And we also include it. Let's take a look at range. So with range, we start the smallest y value, which is this one right here, also a negative 3, and we go up until, boop, with the other one, which is the positive 3. So my y values is negative 3 to positive 3. All right, last one. Is this a function? Well, it's a line. Okay, let's see. If I drop a vertical line, sorry, these aren't perfect vertical lines, but notice they only hit in one place. So we're good. This is a function. By the VLT. Okay, so this is a function. Awesome. Side note, are all lines function? And be careful here. When I'm talking about a line, I'm talking about the things that are straight. Because in math, all lines are straight. So these two graphs here are not considered lines. If you had something like this, that's not considered a line. A line is something that is perfectly straight, like that one right there. So back to my question. Are all lines functions? Try to think on that for a second. Are all lines functions? Well, what kind of lines are there? Remember, there are slanted lines, like the one we have for C, right here. That's a slanted line. And then there are also horizontal lines or vertical lines. Ooh, you might have seen it. Vertical lines are exactly what we use to do the vertical line test, right? So vertical line is not a function. Vertical lines are not functions. However, horizontal lines and slanted lines are functions, but vertical lines are not. So, to the question, are all lines functions? The answer is nope. Okay, so vertical lines are not functions because they are the exact reason how we check, or sorry, they're the exact way that we check if something's a function. Okay, that was a long tangent. Here we go. Last thing, domain and range. Try to find these by yourself. Okay, domain, x values. Farthest back x value we're looking at, well, that goes on to infinity, and that end goes on to infinity. Those arrowheads indicate infinity, which means negative infinity to positive infinity. Now let's take a look at the y values, right up here. Well, that arrowhead also indicates it's going to keep going down, and that arrowhead also indicates it's going to keep going up. So, negative infinity to positive infinity. Alright, and that is it for this section. Once again, if you have questions, feel free to drop by my office hour or email me to set up another time.